Hi, welcome to the third course dedicated to the GAMA platform. In this course, we will present to you how to write a simple epidemiological model. In particular, we will see how to define species of agents, to create them, and to display them. In our simple epidemiological model, a simulation step represents 5 minutes. Only one species of agent is taken into account, the people agents. These people agents are going to randomly move in a continuous environment of 1,500 meters by 1,500 meters and contaminate each other. If a people agent is infected, it will have at each simulation step a probability of 0.05 to infect each of the people agents that are at 10 meters. We are now going to show you how to build such a model. First, we create a new project and a new model. First, we create a new project by right-clicking on a user model and by choosing New GAMA Project. We then choose the name of the project. Once the project is created, it appears in the User Models folder. After creating the project, we create a new model by right-clicking on our new project or by choosing New Model File. In order to start with a basic structure, we choose Skeleton. Then we choose a new name for the model. A gamma model is composed of three main types of sections. The global section that represents all the global features of the model. The species and grid sections that represent the different types of agents, and the experiment section that represent the context of execution of the simulation. First, we define the people species. Species is an archetype of agent and specifies their properties. A species can contain several elements. First, the variables that define the state of the agent. Second, the behaviors of the agent. At last, the aspect that define how the agent can be displayed. In addition, GAMA allows to attach skills to agents through the facets skills. Skills are built-in modules that provide a set of related built-in attributes and built-in actions to the species that declare them. We define a new block for the people species. We attach the moving skill to the people species that provides the agents with several attributes and actions related to movement. Let's add some attributes to the people species. A variable is defined by using the type of the attribute and its name. Numerous types of variables are available: integer, float, string, boolean, point, list, pair, map, file, matrix, color, graph, and so on. In addition, several optional facets can be used to give an initial value to the variable, to allow it to be recomputed at each simulation step or when called, or give a minimum or maximum value to it. In addition to the variables defined by the modeler, GAMA provides every agent with some built-in variables: a name, a shape that is the geometry of the agent, and a location that is the centroid of its shape. In our model, we add a first variable for the people agent called speed. The speed is a float value that is initialized by a random value between 2 and 5 kilometers per hour. Note that the hash symbol can be used to define the unity of a value. We define then a second variable called isInfected that represents if the agent is infected or not. This variable is a boolean that has for false for its init value. Now let's add some behaviors to the people species. The simplest way to define the behaviors of agents is to use reflexes. A reflex is a block of code that is executed at each simulation step if the optional attach condition is checked. At each simulation step, Gamma activates first the world agent, which is defined by the global section, then the other agents in their creation order. When an agent is activated, it begins by recomputing all its variable values that we have an update facet. Then it executes all its reflexes in their definition order. Note that this scheduler can be easily turned with just few lines of code. For instance, to change the order of activation of the agent or to make the agent execute their actions in a given order. In our model, we add a first reflex for the people species called move. This reflex will be activated at each simulation step. When executed, this reflex will apply the wander action that is one of the actions provided by the moving skill, and it allows to make an agent move randomly to a distance computed from its speed variable. We add a second reflex called infect that is only activated when the agent is infected. When executed, this reflex asks all people agents at a distance lower or equal to 10 meters to test a probability to be infected. For that, we use the ask operator that allows to ask a list of agents to execute a set of statements. We use as well the @distance operator that allows to compute the list of agents that are at a given distance to the agent. At last, we use the flip operator that allows to test a probability. For example, flip 0.05 has a probability 0 to 0.5 to return true, and the probability 0.95 to return false. It's time to define how we want to display the people agent. An aspect is a way to display the agents of a species. In a display, it is possible to draw a geometry, an image, or a text. In our model, we define an aspect for the people agent called circle that draws the agents as a circle of 10-meter radius with a color that depends on their isInfected attribute. If the people agent is infected, it will be drawn in red, in green, otherwise. We have now finished to define the people species. It is now time to define the environment properties and to create people agents. The global section represents a specific agent called world. Defining this agent follows the same principles as many agents, and that is defined after a species. The world agent represents everything that is global to the model, dynamics, variables, and so on. It allows to initialize simulations through the init block. The shape variable of the world agent is by default a square with 100 meters for the side size, but can be redefined if necessary. The step variable of the world agent allows to specify the duration of one simulation step. By default, one simulation step represents 1 second. In our model, we define 4 new global variables. The first one is NB people, that is an integer with the initial value of 2147. It represents the number of inhabitants living in our environment, and it will be used to create the people agents. We define a second variable called NB infected init. That represents the number of infected people at the initialization. We initialize this variable as 5. We redefine the step variable in order to set the duration of a simulation step to 5 minutes. At last, we redefine the shape variable in order to set the geometry of the world to a square of 1,500 meters side size. We then define the init section. In this section, we create NB people agents, by using the create statement. Then we ask NB infected init people agents to become infected. Now, to finish, we have to define the inputs and outputs of the experiment. An experiment block defines how a model can be simulated. There are two types of experiments: GUI experiments that allows to run a simulation with its graphical interface, and the batch experiments that allow to set up a series of simulations. Inside an experiment, a modeler can redefine parameters to let the possibility to users to modify the value of a global variable. The modelers can also redefine a display in the output block of the GUI experiment to display agents, images, texts, and charts. We define a parameter to let the possibility to users to modify the value of the NB infected init global variable. Then we define a new display called map, in which we display the people species with the circle aspect. Now that the model is finished, we load it by using the experiment button that corresponds to the experiment defined. We then push on the play button to see the evolution of the system. At the beginning of the simulation, only few people agents are infected, but the number of infected agents quickly increases. We have the possibility in the parameter panel to modify the value of its variable. For example, we can choose to have at the beginning 500 infected agents. To make Gamma take into account the modification of this parameter value, we have to click on the reload button.